Hi everybody. We are starting our next unit, Unit 4. Sorry if you hear noise in the background. The bell just rang for everybody to leave school on Friday, the last bell. So people are probably screaming in the hall. But anyway, today we're going to be doing slope. It is the first day of Unit 4. And yes, Luke, I did put a title page. That was just for you. So let's go ahead and get started. So first question is, what is slope? Okay. Well, slope is the ratio, meaning like fraction, of the vertical change to the horizontal change of a line, basically. Okay. It is also known as rate of change. So how much it's changing over time. Yeah. Um. So here's the formula for it. It's y2, which would be the y value of 1 point, minus the y value of another point, all over the x value of 1 point minus the x value of another point. So you need 2 points in order to do this formula. And that's going to give you the rise over the run, what you guys are used to. So rise over run still. Okay? But now you know it as the change in the vertical change, the change in y over the change in x, because you're upgrading your knowledge. Okay? Alright, so there are 4 types of slope. I don't know why, I just showed you 4 fingers, like you can see this. 4 types of slope, and these are the different kind of lines, so these are different slopes of lines, basically. So this guy, because it's going down, it's negative. This one is going up, it's positive. So that's a negative slope, positive slope. This is going straight up and down, it's a vertical line, so it's an undefined slope. And a horizontal line has a 0 slope. Okay? And now, let me introduce you to Mr. Slope Dude. Or Slope Dude in general. You don't have to be so formal with him. But, anyway, what's nice is that his face gives you a lot of information about slopes. So, here we have his one little eyebrow, and look, it's going down. That means it's a negative slope, so it's like a negative eye. He doesn't like that. He's mean there. This one is a positive slope, because we always want to read it from left to right. Left to right, okay? So it's going up, so there's his positive eye. This is a straight line, which means it's an undefined slope, so that makes his nose. And here we have a horizontal line, which means it has a 0 slope, making his mouth. And little dimples for his mouth, too. This is also on my wall in my classroom. And 6th period, it should be in your classroom, too, soon. I'm working on it. Alright, finding slope from a graph. So, first thing is you pick 2 points from the line. Then you count the vertical distance between them, so up and down, the y's. And then you count the horizontal distance, so from left to right. Again, I'm still using my hands, and like you guys can see it. And 4, we put the vertical distance, the rise, over the run, and we get the fraction for the slope. And we always want to make sure this is in simplest form. Okay? So let's practice. Finding slope from a graph. So we want to pick 2 points. Some points will be very easy to see. You want to find them on these intersections of the grid marks. Sometimes they're not always that easy. So what I go for is usually the x and y intercept are pretty easy to spot. So I usually pick those 2 points and just do it from there. So first I need to do my vertical change. I think someone's knocking my door, but I'm going to ignore them. So I'm going to go ahead and just go up. And I go up 1, 2, 3, 4, 5. So that is my rise. I went up 5 things. And then, so now I got to do my run. So I'm going to do my horizontal change. So I'm going to go over 1, 2, 3, 4, 5 spaces. So that's my run. Sorry, Auntie. So my run is 5 spaces. So because I went up, it's positive. Because I went to the right, it's positive. So, because that's also where the positive numbers are headed for both directions. If I was going down, it would be -5. If I was going to the left, that would be -5 as well. Okay? So up and to the right, those are both positive. So now I got my rise and my run. I make it into my slope. So M is also the way we denote slope. So I do 5 over 5, I simplify it, I get 1. So that's my slope. Okay, try this one on your own. Go ahead and pause the video and try it. And then when you come back, we'll move on. Okay, yeah, I know, you're just sitting there for 2 seconds waiting for me to talk. So now we're going to go ahead and find slope from an equation. So let me introduce you to this. Y equals mx plus b. That is, slope-intercept form, which will come back, so don't forget it, because you'll use it all the time. Okay? So this is slope-intercept form when it looks like y equals mx plus b. We know that m is our slope, but b is actually the variable we use for a y-intercept. So slope-intercept form means we have slope and our y-intercept in the same, present in the equation. So what we're going to have to do is make sure that we get it into slope-intercept form, and then we can find our slope really easily. So guess what? We're going to try it. So here's an equation, 3x minus y equals 16. We need to isolate the y. Because once we get the y by itself, we should have slope-intercept form, and we're good to find the slope then. So the very first thing we need to do is get rid of this 3x, because that's with y, and I don't like it. So we're going to subtract 3x from both sides. You guys can do it underneath the 3x. I can't do that on a computer, so subtract 3x from both sides. The 3x's cancel out here. I can't combine these because they're not like terms, so I just leave them alone. So now I have negative y equals negative 3x plus 16. Oh, it's the other. So now I have to get rid of this negative 1 with this y because I don't care what negative y is. I only care what y is. So I'm going to divide every single term by negative 1. Okay? Every one of them. This is where you have to kind of do it. You have to divide everything by negative 1. Okay? So, negative 1 divided by negative 1 will give me positive 1. Negative 3 divided by negative 1 will give me positive 3. 16 divided by negative 1 will give me negative 16. So my new equation is now y equals 3x minus 16. Where 3, because it's the one where the m should be in slope-intercept form, it's always going to be the number with the x, is my slope. Where did I put it? There it is. Slope is 3. Okay? So now you're going to try this one on your own. Pause the video, do it. When you come back, we'll move on. Okay, we're moving on. And here we go. So finding slope from 2 points. So this is where the equation comes into play. So you pick your 2 points. Oh my gosh, such a long bell. Yeah, I forgot to do this at the beginning of 7th period, so I'm doing it after school now. Because go Miss Scully with planning. Woo! So point 1, whatever point you pick, that's going to be your x1 and y1. Okay? Point 2 will give you your x2 and your y2. So you're literally just picking 2 points and pulling the x and y's from those points to fill in your formula. Okay? Alright, so let's go ahead and try a problem. So here, find the slope of the line given it goes through negative 1, 4, and 6, 3. Okay? So I'm going to go ahead and assign which one's point 1 and which one's point 2. So this is point 1, so x1 is negative 1, y1 is 4. Point 2 is this guy. So x2 is 6 and y2 is 3. Now that I know that, I can go ahead and plug it into this formula. I'm literally just, instead of writing y2 and y1 and x and all that stuff, I'm writing in the numbers now. Be careful and use your parentheses. Okay? So I go ahead and plug it in. Oh, and look at that. So I have 3, which is my y2, minus my y1, 4. And then I have 6 minus my x1, which is negative 1. So this is probably where you would accidentally put 1 minus sign. Okay, it's minus the negative number. So 3 minus 4 gives me negative 1. 6 minus negative 1 really means 6 plus 1, which gives me 7. So negative 1 over 7 is my slope. Ah, I know, it's amazing. So now you're going to do this one on your own, and then you'll be done with your homework. Less than a 10-minute video. I'm amazing. You guys are amazing. Have a great weekend. If it's already past your weekend, I hope you did have a great weekend. And that's my cue to leave. Bye!